So half mole of an ideal gas. To find temperature, okay, so let us find temperatures as ABCD. Now temperature at A is equal to pressure at A into volume at A divided by number of moles R into R, right? Following the ideal gas law, PV, as for all cases, PV equal to nRT. That is why you can find temperature by this PV by nR. So this will become pressure at A is 100 into 10 to the power 3 Pascal into volume is 5000 into 10 to the power minus 6 meter cube divided by half into R. R is 25 by 3. So let's see how much it will become. So this is 3 plus 3, 6. So you get how much? Uh, and this 5 and 5, right? And this 5 and 2. So you get 436 into 2, 120. 120. So its temperature is 120 Kelvin. Temperature at A. Now temperature at B, pressure is same, just volume becomes double at B. So it becomes 240 Kelvin, just double. Temperature also becomes double. And temperature at C. See, temperature at A, C, and B and C, at C, pressure becomes just double. Okay, so it becomes 480 Kelvin, right? See, that in this short way, temperature between B and C you can compare temperature in the following way. Between B and C, that is temperature of C divided by temperature of B is pressure at C divided by pressure at B, because volume is same, constant. And now you have to find temperature at D. Now temperature of D divided by temperature of A is 2. So it is temperature at D is also equal to 240 Kelvin. So thus we have found out all the temperatures. So temperature at A 120, B 240, C 480, and D again 240. Now we have to find the amount of heat supplied in the process AB and BC. So heat supplied in the process AB. Let's find out. This is part A done. So part B, heat supply. So QAB is equal to, it's a constant pressure process. So it is NCP times TB minus TA. So gamma is 5 by 3. So CP is how much? So gamma is 5 pi by 3 means CP minus CV equal to R, and CP by CV equal to gamma. So CP is gamma R by gamma minus 1. and Cv is R by gamma minus 1 simply. Or for diatomic, so this is a monoatomic gas, so Cv is 3R by 2 and Cp is 5R by 2. So you can substitute directly Cp as 5R by 2. So number of moles is half, N is half multiplied by 5R by 2 multiplied by 240 minus 120. So that becomes 1 by 4 into 5 into R is 25 by 3 into 120. So what do you have here? 3 4 3 4 12. You have 10 here. 1250. So that is 1250 joule amount of heat supplied in the process AB. So this is for process AB. So explain it again. So amount of heat supplied in the part AB. See, AB, A to B is a constant pressure process. See, pressure, see this is a graph of pressure versus volume. Here you have pressure in the y-axis, x-axis you have volume. So A to B is a constant pressure process. So B to C is constant volume process. C to D is again constant pressure process. D to A again constant volume process. So in a constant pressure process, what is heat equal to? N into Cp, specific molar specific heat at constant pressure into difference in temperature. So Tb minus Ta. So Cp, Cp is 5R by 2 because Cv is how much? Cv is F by 2R. F is 3. So Cv is 3 by 2R. So Cp is 5 by 2R. So it is N, which is half, into Cp, which is 5R by 2 into difference in temperature. That means temperature at B minus temperature at A. 240 minus 120. So you get 1250 joules. Now we will find out temperature at, that heat supplied in the process BC then. So AB is done for heat supplied in the process BC. So QBC, so BC is a constant volume process, right? So it is NCV into TC minus TB. Okay. So what were the temperatures? What were the temperatures here? No. Oh, it was 120, I guess. Now 120, 240, and like that. Let me write down the temperatures. TA was 120 Kelvin. TB was 240 Kelvin. TC was 480 Kelvin. And TT was again 240 Kelvin. Okay. So Q from B to C is NCV into TC minus TB. So N is half. What is CV? 3R by 2 and TC 480 minus TB 240. That means it is 3 by 4 into R is 25 by 3 into 240. So 3 and 3 will cancel. So you have here 3000. You have how much? No, for 1500, right? 1500 joule. So QBC comes out to be 1500 joule. Okay. So now part C, heat liberated in the process CD and CA. Suppose heat gained in the process CD, we expect a negative answer because heat liberated, na? Because see, from the diagram you can see that heat is lost in the process. But by convention, QCD is heat gained. We expect it to be negative. So it is N again CP, constant pressure process, into TD minus TC. So what you have here equal to N is half into Cp 5 bar by 2 into Td 240 minus Tc 480. So already you get a minus sign here. So minus 5 by 4 into 25 by 3 into 240. So what you get here, QCD, therefore QCD is equal to uh, it comes out to be 2500, right? 2500, sorry, minus 2500 joule. So therefore heat liberated, that is heat lost in the process CD is 2500 joule. Okay. Then DA, process DA, heat gained is equal to NCV into TA minus TD, that is half into CV 3 by 2R into TA minus TD. So that you get minus 750 joule. So heat lost in the process D2A is 750 joule.